Okay, let's get started. Hopefully a few more people will come joining in a little late. I'd like to thank you all for joining the next in our series of the First Friday webinars. If you've joined some of our previous ones, you've seen we've done various sound check modules and some applications-based training. Last month we did a webinar on SoundMap, which Pascal hosted. And in continuing along that vein, we're going to do another product webinar this week on our AmpConnect hardware. So we'll do an introduction to AmpConnect in general, and of course introduce the new ISC version of AmpConnect, which we're very excited about. So our topics for this webinar, I'll give you an introduction to AmpConnect, going over what it is, the benefits of using AmpConnect over discrete hardware components, and introduce the new ISC version of AmpConnect. Go through some various applications, just talking about how you can integrate AmpConnect into a test station for these various applications. Now, certainly AmpConnect is not limited to these three that we'll go through, but they make for good examples. You'll get an idea of how it can be integrated. And the last part is talking about communicating via soundcheck and how that all works. I'll show you the USB communication and how that works into writing your sequences in soundcheck to talk with AmpConnect. So what is AmpConnect? Well, if you're not familiar, it basically combines the functionality of two microphone power supplies, an impedance reference for testing impedance on loudspeakers, along with a power amplifier for sending the stimulus to a DUT speaker or for a mouth simulator. And it also has digital I/O functionality and a signal router. So basically you take the functionality of all these different things and wrap them up into one product that is 2 rack spaces high. So going back a page here, if you take a look at all that equipment and all the cabling that goes with it, the clutter on a test system and such, and just simplifying it. And that's really the name of the game with AmpConnect, is simplifying the test system. So that's when we get into the benefits of using the AmpConnect instead of using all those separate components. The main thing is simplicity. So now instead of having all that extra cabling, all that extra equipment, you have one box and all the cabling is done inside. So it makes it easier to automate the system, makes it easier for novice users to get started with. And let's say you have a system that you want to send over to a production facility where you might have less technical personnel. This makes it a lot easier for them to get it set up and get running and less troubleshooting. If you've worked with test systems much, you know that one of the main problems you encounter is people just simply plugging things in wrong. So the less cables you have, the less chance that there is of that occurring. Calibration is also a little bit simpler using the AmpConnect. If you've calibrated an amplifier before, you know that you usually have to disconnect some cabling and reconnect to the sound card to do an electrical loopback and measure the gain of the amp. Well, with AmpConnect, we have this routing matrix that I'll talk a little bit more about, where you can actually electronically send the signal back to the sound card. So this saves you the hassle of having to unplug and replug things and accidentally hook things back up wrong. We can do it all automatically through the AmpConnect interface. Another key benefit is the integration, the fact that we can control AmpConnect directly from soundcheck over the USB. And this allows you to really automate the whole system, and as well as control it through the front panel. So if you want to automate it directly in your test sequences or control it manually, you have a couple different choices of how you want to set it up. And last but certainly not least is the durability. We've designed AmpConnect to stand up to the most demanding production environments, whether it's the humidity of southern China or the arid, dry heat of northern Mexico or wherever in North America you are. AmpConnect is going to stand up to different environments as we have a very durable product. So let's take a look at the different connections on AmpConnect to kind of introduce you. So this is the standard AmpConnect model, the non-ISC version, and here's a view of the back panel. So first off, on the left side, we have 2 microphone inputs. Now these are labeled reference and DUT, which are mainly names. You can really plug whatever you want into these 2 different microphone inputs, whether it's 2 reference microphones or 2 device under test. It really doesn't matter. We've put those labels on there simply as a guide to get people started. So you'll see for each of these inputs, there is a BNC connector and an XLR connector. Now these are wired in parallel, so you wouldn't use both of them at the same time. It would be one or the other. We just want to give you the option of whether you want to use a balanced or unbalanced connection for your microphone. So the next three jacks next to that are only on the standard AmpConnect, not the ISC version. So these are the three cables that will run back to your sound card. So AmpConnect has two outputs, which I'll show you in a second, can be configured to send whatever signal you like. And so we have two cables that will run from AmpConnect back to the sound card to send the signals in. And the third connection over on the side is the input. So that's the cable will run from the sound card to AmpConnect. So this is what you'll send your stimulus through to get to the power amplifier and then go out to your speaker. So similarly to the microphone inputs, all of these connections both have the unbalanced BNC connector as well as the balanced XLR. And at the very top, you'll see the two sets of banana posts for the output of the power amplifier, which I'll talk about those two outputs in just a second. So let's talk about on the front panel of AmpConnect now. Here's one of the sections of settings available, and this would be for the input side. So as I mentioned, we have two microphone inputs on AmpConnect called reference and DUT. And if you look at the screenshot up there, you'll see the two with a little level indicator below. So the level indicator is an LED that will flash green when you have signal going through it, and as the input level starts to get higher, it'll eventually reach yellow and then red when the input is clipping. So you have a separate level indicator for each channel. So currently on this screen here, you see that reference is highlighted. So to the right, under the bias and the gain, we are looking at the settings for the reference channel. And if we switch over to highlight the DUT channel, those settings will change. So all the settings can be set independently on a per channel basis. So for the bias, we have three different choices. There's none, which means we'll supply no bias, voltage, or current. This would be used for testing microphones or electronics that do not require power, or if you're powering them externally before you send the signal into AmpConnect. An example of that would be if you have a pro audio microphone that requires phantom power, you would provide a little front-end phantom power unit and then run your audio signal into the AmpConnect from there. The next option is voltage bias, and this would be to power up the Listen SCM microphones. You could also use it to power Electret condenser microphones, although you would typically have a little front-end circuitry for doing that, customized for your particular product. Now the voltage is by default 10 volts, but this voltage can be adjusted manually by removing the cover of AmpConnect, and there's a little pot that can be adjusted anywhere between 1.2 volts and 10 volts DC. And the final option for the bias is IEPE, which provides constant current bias for prepolarized reference microphones and ear stimulators. So it's important to note that AmpConnect does not have 200-volt bias like we do on the SoundConnect. So if you have some older reference microphones that require 200-volt, you would probably want to use the SoundConnect, which you could then put into the sound card directly, or still route it through the AmpConnect just to simplify things. But we find that more and more these days people are moving towards pre-polarized microphones. Instead of the 200-volt variants, they tend to be a little bit more durable. And so if you're buying AmpConnect and you want to buy some new reference microphone equipment, you can either go with our Listen SCM quarter-inch microphones or go with the Gras or B&K pre-polarized reference microphones and ear stimulators. So each channel can also be set independently for the gain, and this can be anywhere between -20 to +40 dB. And so this can be also set dynamically during your test through the USB control. So let's say you have a portion of your test that is a pretty high signal level, and so maybe you have your microphone level set at 0 dB. But then you have a part of your test where you need to measure a noise level, and you need to boost that noise over the noise floor of your whole test system. So in that case, you could switch it to +20, +40 dB, or whatever is required. Let's talk about the output section. So as we mentioned, there are two outputs for AmpConnect, and they are configurable. So I really tend to think of this section as sort of a digital patch bay, where you assign a signal to each of the two channels. So here are the different options that are available. We have Z high and Z low, which are two different reference loads for testing loudspeaker impedance. So Z high is 1 ohm by default, and Z low is 0.1 ohm by default. Now Z high can actually be changed. If you remove the cover of AmpConnect, you can actually get at that resistor and put in your own custom value if you like. But by default, it's a 1 ohm resistor. So by choosing that, assigning Z high or Z low to one of your outputs, you're sending that electrical signal back to the sound card, which then in sound check you can use for measuring impedance. The next one is the amplifier. So this allows you to route the output of the power amp back to the sound card. Now this would be used for calibration, or if you just want to test out the amplifier. We actually have a sequence called AmpConnect self-test, which does some of this. It does the loop back to check the amplifier, make sure the gain is where it should be. And the next two are the reference and the DUT signal. So we saw we have the two microphone inputs that we just looked at in the other section. And this is how you choose which signal you want to send to each of the outputs. So if you're only looking at the reference or only the DUT, or you can assign them both to channels 1 and 2 if you're doing a 2 microphone setup. And the last section is the 1 volt sine. So we have a built-in 1 volt sine oscillator that you can route to either of your outputs, which is very useful for doing calibration or if you wanted to just do some level checking. Again, that AmpConnect self-test sequence I was talking about makes use of that 1 volt sine to check and make sure you have all your cables set up correctly and that AmpConnect is doing what it should. So another section is the power amplifier, a little bit simpler than the other two sections. There are 2 outputs. Now it's important to note that this is a single amplifier in AmpConnect. We just happen to have 2 outputs for it. So it's not a stereo amplifier. Now you do have the choice to send a signal to either output or to both simultaneously. Sending to both simultaneously would probably not be used terribly often, as you would then be loading the amplifier with 2 speakers at the same time. But the reason you would want to switch back and forth between the 2 outputs is it gives you the capability to have 2 separate sets of fixturing that you switch back and forth between. I'll give you a little example of that in just a moment. Now this amplifier in AmpConnect is a fixed 26 dB of gain. There's no level adjustment, which really makes it nice and simple, especially on a production line, less knobs to fiddle with. And it's a 60 watt amplifier into a 4 ohm load, which provides a lot of flexibility for different speaker sizes. So the last section on the front panel is the digital I/O. This provides 8 bits of digital I/O. It can be written and read directly in SoundCheck. So you might want to use this for communicating with relay boards or switches, or if you want to integrate a foot switch into your system. It gives you a lot of different options, and basically, instead of having to have an NI card installed on your system for doing the digital I/O, you can do it all right here through AmpConnect. I'll show you a little bit about that when we get to looking at the USB control. So the brand new product that we're really excited to present is the AmpConnect ISC. It was sort of a natural thing that people asked about since we first made AmpConnect was, when are you going to put a sound card in it? Well, now we actually have. So ISC stands for internal sound card. So it's all the same features as the original AmpConnect, but now we have a built-in 2-channel USB sound card in the box. So looking at this rear panel view of the new AmpConnect ISC, you see we have a lot less connections back there. And that's because now we've eliminated those 3 connections that you have to make to your sound card, whereas now all of the audio will just be sent over USB. So it's even less cabling than the original AmpConnect, which makes things simpler yet. And that's kind of our whole goal with any hardware that we create for SoundCheck, is just to make SoundCheck easier to use, simpler to set up. Another addition to the ISC version is a headphone amplifier. So we've added a headphone jack on the front panel, which you can use for either monitoring your microphone signals or for testing headphones. Typically, the gain of the main power amplifier on AmpConnect is a little too high for testing headphones. The signal you would have to send out of the sound card would be really low to account for that gain. So having a dedicated headphone amp with much lower gain provides you the capability to test headphones directly from AmpConnect without having an external headphone amp. So now I'd like to show you some setup options for using AmpConnect in different applications. So here's a diagram showing sort of your traditional loudspeaker test setup in SoundCheck. This might look familiar if you've done any loudspeaker testing. So we have the output from our sound card, which sends the stimulus signal to a power amplifier. That then is routed through the impedance reference box, which also has a signal split off from there back to the sound card. The other end of that impedance box goes to a speaker under test. We have our measurement microphone connected through a AmpConnect power supply, and then back to the sound card. Now, it's not terribly complicated, but you can see you have a number of pieces of equipment as well as quite a bit of cabling. So you can see the difference it makes when we switch over to the AmpConnect setup. So now instead of having all those different pieces of gear, we have one box, much less cabling. So we just have our 3 cables that are sent to the sound card with the traditional AmpConnect, and then a connection to the loudspeaker and the measurement microphone connected back through AmpConnect. So very clean, very simple setup. Now if we go to the new AmpConnect ISC version, it gets even simpler yet, because now instead of having 3 cables going to the sound card, we have one USB connection that goes to the computer, one connection to the speaker, one to the microphone. 3 cables, and you're done. So this is great, especially for the production environment where you want to keep things as clean and easy as possible, as few cables to go bad as possible as well. Now here's an example of the dual speaker setup I was talking about. Now this shows it with the original AmpConnect, but it would pretty much be the same thing with the ISC version, just it wouldn't have the cables going back to the sound card. But you can see we have the output A and output B of the amplifier are going to 2 different speakers. And then we have 2 measurement microphones that are connected back to the reference and DUT microphone inputs. And so the idea is that you would be testing speaker 1 while the operator is setting up speaker 2. Once they've finished that, vice versa. And we can actually configure the software to go back and forth between speaker 1 and the 1 measurement mic and speaker 2 and the 2nd measurement mic. So this gives you a little bit of flexibility if you want to try to create sort of a high volume setup using AmpConnect. This can be done for a loudspeaker or a microphone setup. So I'd like to show that AmpConnect isn't just for doing loudspeaker testing. It's certainly very applicable for doing microphones as well. So this example here, we have the AmpConnect ISC, and it would pretty much be the same thing for the original AmpConnect as well. So now instead of connecting a loudspeaker under test, we have a mouth stimulator hooked up to the output of the power amp. So we're playing our stimulus through the mouth stimulator, and then we have 2 microphones hooked up at the same time. We have our measurement microphone for doing either calibration or recording a reference curve, and then our DUT microphone hooked back in as well. Headphone testing is another great application now with the ISC version. So this would be the only application I would say you would definitely want to use the ISC version. The traditional AmpConnect does not have the headphone amplifier. So you see with this setup here, we have our headphones connected through that headphone jack on the front of the unit. And then we have 2 ear simulators, which we would want to be pre-polarized microphones, going back to the reference and the DUT inputs. So we can play out through both the left and the right headphones and record back on the left and right ear simulators all at the same time and have a really clean and efficient headphone test setup. So controlling AmpConnect, you have 2 different options. We have these buttons on the front of the unit, which you can use to configure just about every parameter of AmpConnect except for the digital I/O. So you have the capability to change the microphone settings, change the outputs, change the power amplifier settings, all through the front panel. So if you have your AmpConnects on a bench or you don't really want to write the automation into each of your test sequences, you can do it all manually if you'd like. But if you do want a little bit of control and really integrated automation, then you have the USB option. So through SoundCheck, with this nice little interface that we've built, you can send all of your communications to AmpConnect directly and write it into your test sequence. So So this allows you to make changes on the fly, like during the sequence. If you want to have different settings at different parts of the test sequence, you can configure this little application to make the changes as you go. So to demonstrate that a little bit, I think I'm going to bring up SoundCheck now and show you how to go about setting up your AmpConnect. So I'm showing here SoundCheck 10. Now we introduced AmpConnect when SoundCheck 9 was available, and we had a control for it, but it was through a custom VI. So for SoundCheck 10, we had the goal of really further integrating AmpConnect and making it easier to set up. So now, just like all of our other pieces of hardware, the first thing you have to do is add your AmpConnect to your hardware step, just like you would with a DC Connect or with a digital I/O card or anything like that. So I go into my hardware step, and you see we've added here a tab for AmpConnect specifically. And if I go into this tab, first I'm going to enable it, and then click Add to add in my device. So when you install SoundCheck, the AmpConnect software gets installed automatically along with the driver, regardless if you actually have an AmpConnect. So once you get your AmpConnect hooked up, you should be good to go. It's pretty much plug and play. And the nice part about that is that now when I click this drop-down box here, SoundCheck has already found the AmpConnect that I have hooked up. So I see the serial number here, select the device, and click OK. So now it's been added to this table here. I have device ID 1 with my serial number, and my status tells me it's connected. So if you had multiple AmpConnects hooked up at the same time, then you would have more device IDs going down the table here, and you'd be able to see the serial number of each one individually. Now, the device ID is important, as we'll be using that when we go to communicate with it through the message steps. So this is the same whether you're using the traditional AmpConnect or the new ISC version. Either way, you'll need to go through here and set this up if you want to communicate with it through the USB. Now, since I am using the ISC version right now, I am also using it as my sound card. So on the audio tab here, if I open up the table view, you see I have 2 input channels, 2 output channels, and they're all currently being assigned to AmpConnect USB sound card. So all of my signals, all my audio is just going direct in and out of the computer through the USB connection. Okay, so now that I have my AmpConnect added to my hardware step, I can now communicate with it directly in my sequence. So just like all of our other pieces of hardware, things like RS-232 or GPIB, digital I/O, the way we communicate with AmpConnect is through a message step. If you've seen some of our previous webinars, maybe you saw our message step webinar that went through how to do all that. Well, now we have a new section in the message step. So let me add this default step into my sequence. You see, in addition to the previous options that were available here, we've added one down at the bottom called AmpConnect. And so once we're in that mode, first thing we need to do is assign the device ID. So right now we only have the one AmpConnect, so that appears here under device ID 1. And of course, if we had other AmpConnects, it'd be 1, 2, 3, 4, however many are available. So I choose device ID 1, and now I can click this Configure AmpConnect button to open the panel. So the nice thing about this whole interface is it exactly mirrors the front panel of the AmpConnect, so it makes it very intuitive to set it up. You have a few choices for getting started and creating your AmpConnect setup here. One way to do it would be to set up all your controls the way you want them through the front panel interface on the AmpConnect. So if I've been using it sort of offline and now I want to mirror that setup and make sure that every time I run this sequence it uses the exact same setup, I can click this Read Settings button. And when I do that, this whole panel reconfigures itself to match exactly what's on my AmpConnect right now. So that's an easy way to set it up. But let's say I want to actually make some changes to it. I want my DUT channel here to be set for 0 dB. I want my reference channel to be set for +20. And I'll leave my outputs alone. So if I want to now apply this to my AmpConnect, I can click OK, and I can run my sequence, and then this whole configuration will be sent to the device. Or if I want this configuration to take place right now, I can click Apply, and it will apply it in real time. So the digital I/O section over here has the read and write capability for these 8 bits. So currently on my AmpConnect, all of these bits are actually set high. So you see that since I'm setting them to read, when I applied this step, or when this step would have run in the sequence, it tried to read back all 8 of these bits, and it saw that they were not matching what's currently on the AmpConnect, so I get a failed. So if I go back through here and write all of these to set them back low, and now when I read them back again, I get a pass. So basically, when you're reading back bits, AmpConnect is going to tell you if the state of the 8 bits matches what you have on here right now. So if I change just one of these high, it tells me no, that's not the way it is right now. It registers as a fail. So you can use these 8 bits to read back and make decisions on the pass-fail. Let's say you want to set a bit high when you're ready to actually start the test. You could write that into your sequence to don't start the sequence running until this step passes. So there's a little bit more information about how to go through and set up all the digital I/O in the AmpConnect manual. So for the other sections over here, we have the USB and panel control. So this is a way that you would lock out the front panel so that operators can't make changes to it, or people accidentally bump into it or whatever. So currently I have front panel disabled, so if I press buttons on the front of the AmpConnect, it won't actually do anything. So you can choose to have both USB and panel control enabled at the same time, which will allow you to make changes from either place. So for setting up the input settings here, you see as I toggle back and forth between the reference and the DUT channels, these settings over here change to reflect what is set individually per channel. So you can go through and set your bias, set your gain per channel. And similarly with the output settings, as I change through channel 1, channel 2, it shows me what signal is being applied to that channel at a given time. So let's say I want to change channel 2 to DUT. So now I have channel 1 assigned to reference, channel 2 assigned to DUT signal. So that'll send my 2 microphone signals back to my 2 of my outputs. And on the power amplifier side here, you see we can choose to send outputs A and B simultaneously, or we can just choose one or the other. Now this is kind of an interesting feature here, the toggle inputs, toggle outputs. You would use these checkboxes if you were setting up the one case I showed you earlier, which was for the dual speaker setup. So if you want to have an operator setting up one speaker while testing another one, this is how you do it. If you check off these boxes, when this step runs in the sequence, it's just going to keep switching the output back and forth between output A and output B, and switching the microphone from reference and DUT. So this will allow you to go back and forth in your sequence. So each time you run the test, it'll use the other set of channels. Okay, so once I get my settings the way I want them, I can click OK, and when I run my tests, it'll run this configuration right at the beginning. So this is a good way if you want to make sure that you always have the exact same settings whenever your sequence starts. It's just put an AmpConnect step at the very beginning to configure everything. But let's say you want to change the settings at the end of the test to something else. So I can put in another AmpConnect step. But there is a caution here. If you've attended any of my webinars where I've gone through sequence editing, you'll know that I love to harp on black fields versus blue fields in any of your step editors. So the only thing in this message step that's a blue field is the device ID. So that's the only one that is specific to this instance of the step. Everything else is a black field and thus is a global parameter. So because I have 2 of these in my sequence now, if I go through and change all of my settings in here, and I click OK, I will now have changed it for here and for this instance up here. So you have to be a little bit careful with your message steps. So my rule of thumb with this would be if you're going to use the second AmpConnect step, first thing you would want to do is do a save as. Make a new version of that step. I already have a 2, so I'll make a 3 this time. So now that they have a different name, I can go through and configure this and not have to worry about accidentally making changes to my previous one. So let's say in this particular AmpConnect step, what I want to do at the very end of my sequence is turn on the panel control. So I've disabled it during the sequence, but at the end of the test, I want to re-enable it in case I want to go through and manually do any changes. I click OK. So now I have my two different AmpConnect settings. So when I go to run my sequence, it runs my AmpConnect at the very beginning, it made all the changes, and then runs it once more at the end. I don't have a speaker hooked up at the moment. And so my sequence finishes running. You can see that those messages happened pretty quick. You didn't even really see them pop up, and they didn't really add much time to the overall test. So that's the USB control. The last thing I wanted to show with AmpConnect, or demonstrate for you, is on the ISC version, we have a little utility now for communicating with the headphone amplifier. So through this little utility here, we have a level control that we can change the level through our headphones. And we also have this switch here to choose what you want the headphones to monitor. So we have the A to D and the D to A. So if we choose to monitor the A to D, what we'll be listening to is the microphone inputs. So if you wanted to monitor your signals during the test and just listen on the headphones. If you choose the D to A, you'll be monitoring the output, the stimulus. So in that case, this is how we would set it up to actually test headphones. We would want our stimulus to be routed to the headphones. So just a simple little utility to go and configure that jack. Okay, so let's go back to our webinar window and answer any questions that people have. There was a question, can AmpConnect be used standalone, or does it require sound check to use it? It's a piece of hardware, so it could be used standalone, but really the whole power of this piece of hardware is that we've designed it to fully integrate with SoundCheck. So if you aren't using it with SoundCheck, you'd really be kind of missing out on a lot of what it can do. It would just then be a basic power amplifier with a microphone power supply.